chance to eat. Why? Because insufficient of resource. Okay. The only solution is if the philosopher could have two chopsticks, then only he can eat. Clear? So here we could see that circular weight takes place. Clear? You see the immediate statement below. If all the philosophers become hungry at the same time, then what do? This is what the situation occur. First, they start picking the left chopstick, and what will be the value of chopstick then? Initially, it was 5. When every philosopher pick their chopsticks, then the value becomes false. 0. Okay, so what the philosopher is doing? Waiting for the right chopstick. Now you see, if we again think over the same solution, there is a possibility, at least we could make one or the second philosopher can have or can start eating as they are really hungry. Now let us think the same solution in other side. Now you see here, there are two philosophers. What if we make the solution in this way or think in this way? Let we allow two philosophers to start eating first. So what do? We give 4 chopsticks, 2 for first philosopher and remaining 2 for the second philosopher. Okay. And how many chopsticks remain now? How many chopsticks are left?
One, ma'am.
One is left with some other philosopher. Okay. Now, if this situation arise, now can someone tell me how many philosophers can eat at this instance of time?
2.
At least 2 philosophers can eat. Okay. It means some sort of solution could achieved to some extent, right? But what if we have another chopstick? Then we would have allowed the third philosopher also start eating. But what this philosopher is doing, he had or he held with one chopstick and he's waiting for other chopstick. And there are two more persons who have not yet held with or allocated with at least one chopstick. So simply what they're doing, they are waiting when these two when these two philosophers release chopsticks. Okay, now along with the deadlock, I've also explained you the starvation concept. Have you find the differences between them? We have understood the same solution that there's a possibility of deadlock situation arise. Now with the same solution, if we think in otherwise, starvation problem is occurred. What is the situation where the starvation is taking place? I've explained, I've shown the along with the demonstration, right? So what was that? Deadlock and starvation. So what is that demonstration example?
Barber.
Very good. Sleeping barber problem. Okay, there was one fellow who came after first customer, it means second customer, who is supposed to wait in a waiting room. When the barber came, he left. Okay, barber could not find, there's no person waiting in a waiting room. So he went back to his room, he slept there. When the third customer arrived, he started serving the third customer. And again, when the third customer is being served by a barber, that second customer came to a barber room. He found that still the barber was busy. He's not even observing that he was the second customer. I mean, the third customer he's serving, right? So it means what? These philosophers may get into illusion that the other philosophers might be busy. They might be still eating. So it means what? They don't even bother that how long they should wait in a waiting queue. They don't even bother that when these two philosophers stop eating, they are giving us signals, but these philosophers in such situation that uh, uh, they could not recognize or identify that the before philosophers are signaling us but we are not, थोड़े लोग बोलते हैं ना, कुछ भी बोलो ये बच्चा सुनता ही नहीं. So they are in an illusion that philosophers are still busy in eating. Okay, so in that situation, the problem takes place. This situation can encounter with a problem called starvation. Now you see, with the first solution, we could make out that there's two possibilities of problems do occur. One is deadlock and the other one is starvation. Deadlock में क्या था? We have assigned or allocated each chopstick to each philosopher. But having one chopstick with each philosopher, they could not eat. That was a deadlock problem. Neither one philosopher could eat nor the other philosophers. And what if we make at least two philosophers to eat by providing two chopsticks, but still the starvation problem taking place? Because the other philosophers could not notify that whether the before philosophers are done eating or not. Okay, so with this inputs, we'll move ahead. Now you see here, we'll came with another solution, that is picking a left side chopstick first, okay, and then picking a right side chopstick. What happens? You see, अगर जिसको होना है जो जल्दी जल्दी chopstick उठा लीजिए बोले तो what happens? This is what the situation takes place. What is that observed by you in this figure with the second solution? If we allow the philosophers to pick the left chopstick and then right chopstick, is there any one philosopher at least could get two chopsticks? Observe the figure carefully. If I go by the simply explanation part, you may not be able to understand. So at least by these figures, please try to rectify the problem and understand the concept. If we allow the philosophers to pick chopsticks, one from left and one from right, did we mention that you philosopher, the first philosopher, you start picking the chopstick first, then the turn comes to next? No. Is there are no such statements like what we have learned under two process or hardware solution, that giving a turn to the other philosopher. There's no such situation to arise in second solution. So what is happening if we allow such case towards dining philosopher problem? So what is that objective or outcome we could make out is there are only three philosophers could uh, held with left chopstick. Okay, and when the time comes looking for the right chopstick, there was only one philosopher could held with right chopstick as well. Now if we provide such solution, then what happens? Only one philosopher could start eating. If we think about the previous solution was at least better than this solution, because at least two philosophers could get two or sufficient resources where they can start eating. But if we just modify the solution little slighter, this is what the outcome is. What is the outcome? Is the solution better than the previous one? Observe the figure carefully. There was one philosopher who could not get or allocated with not even one chopstick. Okay, this is the one philosopher who is blindly sitting. Okay, and there was one philosopher who is really hungry, who is sharp enough. Immediately after giving an instruction, he could lift or take left and right chopstick. Okay, and because of insufficient number of resources, the other three philosophers are held with each chopstick. But if the situation arises, only this fellow can complete its work. The remaining other three philosophers having one chopstick will be waiting for another chopstick. Okay, he is waiting for this philosopher. When this philosopher will release this chopstick, do you think that this philosopher is going to release the chopstick? No. Why? Because he is waiting for another chopstick which is held with this philosopher. So कहाँ पे you can break the chain? Here itself. Clear. Only if this philosopher release this chopstick, then the problem will be solved. Is it really? Does it really happen? No. After him, the turn goes to this philosopher because as he is already held with one left chopstick, and as this philosopher release, then he can get the right chopstick. Okay, it means kya? What is happening in the solution? Only one philosopher could complete their work or finish their eating. After they eat, they are supposed to put the chopstick down. But among the five philosophers, four of them are busy with held with at least one or two chopsticks. But there's one philosopher who is sitting blindly without a single chopstick. Then, if such case arise, then the starvation takes place. Now you see, you correlate the sleeping barber problem with this situation. What is he thinking? Even if this fellow release the chopstick, immediately what he can do? He can pick this chopstick at least, isn't it? Now, if this fellow is in an illusion that अभी किसी का तो नहीं हुआ, then why should I waste my time? I'll wait for the two chopsticks released by at most two philosophers. Then I will start thinking whether to eat or not. Okay, so with the situation, we can understand that this fellow might not be really hungry. Okay, so we need to make out one thing, we need to find out that how many philosophers are really feeling hungry. Okay, so at least if we think in that point of topic or a statement, then we would at least reach to some extent of proper solution. Let's proceed. So here we come up with the solution 3. Okay, now we could make out that there's a possibility of problems where the deadlock takes place in the first solution, and in the second solution, despite of providing two chopsticks for at least two philosophers, still the deadlock is taking place. Not only that, the starvation is also occurring. Okay, now well, at least we'll try out in the third solution where some of the problems may resolved or overcome or not. Now you see, is there any additional item or a icon or a image added to this slide? Did you?
Waiter.
So here it is mentioned that use of arbitrator. Guys, you won't find these different types of solutions in the textbook. Even if you find, it will be in like Tare Zameen Pe language. So better you take the screenshot. Otherwise, don't worry, I'll send you this material. Okay. Now you see use of arbitrator. So what is arbitrator is nothing but a third party, or sorry, some other person called as waiter. So let us try to overcome the problem by using a new person or extra person called waiter. Now, what does a waiter do? Sitting five philosophers around the table. Okay. Now, whichever philosopher is really hungry, they call the waiter. Okay, that is what you do sitting in a canteen. No, it is not available in the canteen, but at least the restaurants, right? Now, the customer will call the waiter saying that I want to eat. So he start, क्या बोलते हैं उसको? Items or picking or selecting some items from the menu, right? Now, what is that response we get from the philosopher is, I want to eat. Okay, now the philosopher is saying his willingness that I'm hungry, I want to eat. Okay, he is informing that I'm hungry to whom? Waiter. Now, what does the waiter do? He checks. He simply don't say that you start picking the chopsticks. He only respond to the philosopher by checking enough resources. Okay, if enough resources are available, then you will get some response from the waiter. Now you see, After his or to his request, the waiter respond, okay, you can pick. So the first philosopher picked two chopsticks. Okay. Now, Mr. Swinesh, can you tell me how many chopsticks are left on table?
3, ma'am.
Very good. Now, three chopsticks are available. So it means three enough resources are available. Now, by this figure, you might have understood that what will be the next scenario. Now, which philosopher is saying? Is he the immediate philosopher? No, right? If we start counting this number one, the third philosopher is saying his willingness that now I want to it. Now, what is that response you guess or you're expecting from the waiter? Quick. In the first scenario, philosopher has said that I'm hungry, I want to eat. Now he is waiting for the request to be granted from the waiter. Why? Because waiter is checking are enough resources available on the table or not. Okay, so he respond to the philosopher. Only after his response, the philosopher took two chopsticks. Now, the next philosopher started showing his willingness that I want to eat. Now, I'm asking you, the question is, what is the response which gives by the philosopher?
He can pick the fork.
Will he say that you can pick? Let's see. Yes, he's saying that, okay, you can pick the chopsticks. This is how the figure goes. Now, as of now, two philosophers have are held with two chopsticks. Now, can they eat now? Yes, they can eat. Now you see, there's one fellow waiting. Okay, waiting in the sense, why am I pointing only to one philosopher particularly that he's waiting? Huh?
Wants to eat.
Because he wants to eat. Okay, that is the point you have to observe here, with which you can distinguish this figure with the before solution figures. Okay, only if those philosophers are willing to eat, only those philosophers will be residing in the waiting queue. This you have observed in hardware solution. Am I correct? Test and set, swap instruction, that is which satisfies three critical section requirements using waiting of I boolean variable, data structure, and the other one is lock and flag boolean variables, isn't it? So those processes who are waiting to acquire a lock, only them are going to wait in a waiting queue. Now, similarly, among the three left philosophers, one philosopher is showing his willingness by saying that I want to wait. But as of now, there are insufficient number of resources. That is, only one chopstick is left. Even that chopstick is allocated to the requested philosopher, he could not eat because he need one more chopstick so that he can start eating. Okay, but at least we could see that there is some willingness is being shown here. If that is the case, they simply wait. They may wait till that extent when the left philosopher or right philosopher, if any of them put down the chopsticks. Clear? Now you see, let me ask you one more question. If the right philosopher put down both the chopsticks, can this philosopher start eating? Can he eat? Direct question, can he eat? I repeat, as of now, among the five philosophers, two philosophers are held with or took two chopsticks. अब टेबल में कौन सा कितने चॉपस्टिक है? Only one chopstick. That is between these two philosophers. Now, there's one philosopher among the three who is saying that I want to eat. So what is this? What is he doing? He's simply waiting in a queue, unless these two philosophers release their chopsticks. Now, let us think at one point of time, what if the right hand side philosopher release chopsticks? Can this waiting philosopher come out from the waiting state?
No, ma'am. No,
No.
ma'am.
Why? The reason is he need one more chopstick which is held with the left philosopher. Okay, agar if this fellow has to be served, then both the philosophers has to release both the chopsticks. Okay, now that was a problem which do arise only if both the philosophers at the left and the right hand side release their or put down their chopsticks, then only the waiting philosopher can start eating. Otherwise, if this philosopher, as of now, we could see that this philosopher is not really hungry, even if this philosopher put down both the chopstick, it is no use. Why? This fellow is not angry. He don't like the item, I guess. So it is waste of having chopsticks on the table, which is not utilizing by the philosophers. Okay, this kind of problem we have noticed or observed with the help of third solution. Okay, now with that, we're moving towards the last solution, that is solution number 4. Uh, as it is mentioned that it is Tannenbaum's solution. So what is Tannenbaum? Is it a name? How many of you heard this word? Is it familiar one? In the first year itself, you might have heard this name. Yes, yes or no? Quickly. Come on, guys. See textbook author. Okay, fine. Let us not talk about unnecessary issues. Can someone tell me what's the time now?
11:30.
Okay, more 15 minutes. Fine. Now let's least we'll think of at least this solution will satisfy the objectives of uh, dining philosopher restrictions, where it achieves the outcome or overcome the problem with this appropriate solution. Now you see, uh, are there any different things are rendered here compared to the before solutions? Something I've told you the first slide itself, 3 parameters. If we consider 3 parameters, then I mean, there is a possibility to uh, clear this problem. What were they? Knowing the status of the philosopher, knowing the status of the philosopher. Is that clear? See, the 3 parameters over here, lying over here, which depicts the status of the philosopher. Firstly, which philosopher is hungry? Okay, and if there is sufficient resources are there, is that philosopher thinking to eat or not? If he fasts in thinking, then he fasts in eating as well. Okay, thinking fast, इसका मतलब ये है कि when the chopsticks are lying on the table, if he is thinking fast that really, yes, I'm hungry, he is fast enough, then before the other philosopher pick the chopsticks, this fellow will start picking the chopstick first. Okay, so that is the beauty of this solution. First of all, he should be hungry. A philosopher should be hungry, and he should think fast in picking the chopsticks, right and the left side, and start eating. If he start eating fast as well, then he can put down the chopsticks fast, so that the same chopsticks can be used by the other philosophers. This is how the all the philosopher क्या बोलते हैं उसको, सबका hungry satisfies हो सकता. Clear? And apart from that, not only knowing the status of the philosopher in serving or allocating the resources, that is chopsticks, but also maintaining two semaphores. The first semaphore, Do you remember in the before solutions also, in the before problems also, we came up with the solutions using semaphore and the other one
Mutex.
mutex. Okay, if and only if we could use semaphore and mutex, we've achieved the mutual exclusion or the appropriate solution for the given problem. Now, similarly, this author has thought of using, why not to use not only the semaphore concept but also use mutex mechanism in fulfilling this concept. It means providing sufficient resources at that particular instance of time. So maintaining two semaphores, at least it could overcome the problem. So the first semaphore is the general semaphore, which uh, initially set to 0, as we have 5 number of philosophers, so it can reach till 5. Now, can someone tell me, is it a binary semaphore or a counting semaphore?
Counting.
Very good. So remember, if it is a counting semaphore, the semaphore value will initialized with 0. Okay, इसका मतलब ये है कि there may be more than one or a two or more than that. Clear? So in this particular type of semaphore, what happens? It simply increment by 1. Clear? Now, if it is a binary semaphore, which is also called as mutex, so such type of semaphores are initialized with, answer is on your screen.
1.
Very good. 1. Okay, so it means what? Only one process can acquire a lock upon its resource, and he is the ownership. He has all privileges of ownership where he can release lock. So what happens? It decrements by 1, which becomes 0. Saying that agar maine tala dala to I do have a right to release the lock. Is that clear? So I hope you understood that two types of semaphores are used under fourth solution, that is general semaphore, which is second category called counting semaphore, and it is initialized to 0. Why? Because there are 5 chopsticks, 5 philosophers. Okay? And acquiring a lock should be done only by itself. Okay? So that is why the mutex locking mechanism is also used. Whenever you use mutex, remember one point, important point, whenever we use this technique, it means this solution will for sure satisfy mutual exclusion requirement. Okay, याद रखिए ME mutex. This is also known as a binary semaphore, but also this helps in satisfying mutual exclusion requirement of critical section problem. Now, if you see in detail, inculcating the first 3 parameters, that is, what are those three parameters? Hungry, secondly,
Thinking, eating.
thinking and eating. Okay, so if he or if so and so philosopher is hungry, then this test instruction will execute. What is that we all have in test instruction? I'll show you in the next slide. Okay, so if he's really hungry, he's thinking fast, then he immediately pick the chopsticks. Okay, now after he could find that there's one philosopher waiting, which the help of signal, then he put down the chopsticks. Okay, acquiring a lock, releasing a lock in terms of hungry. If he's thinking fast, even he should make sure that am I allowed to enter into a critical section or not. Okay. Now these statements, they represent that yes, there's one philosopher might be at the left hand side or right hand side is willing to eat. So if you are signaled with such flags or something variables you use, then what do? As of now, if you are not eating, if you are satisfied with the first step, then what do? You put the chopsticks down so that you allow the other philosophers to pick the chopstick and start eating. Okay, this will possible only if three parameters considered: hungry, thinking, eating. Or every parameter should be in fast enough. इसलिए मैं बार बार stressing कर रही हूँ word पे, that is fast. His he should think in fast in thinking, fast in eating, so that the other philosophers can serve with sufficient chopsticks. Now this is what the test, whenever the test function is being called, this is what the segment of code represents here. So what is all about is, if he is really hungry, first condition satisfies. If he is really hungry, he will also ensure that is my left hand side or a right hand side philosopher is not picked my chopstick. No, if he picked, then what am I supposed to do? I have to wait for it. So I will ensure that right side or left side philosophers, either of them are not eating, then I'll start pick the chopsticks and I'll eat. Okay, and after I'm done eating, I'll signal the other philosopher that I'm done eating. Now whoever is interested or hungry enough to eat, then they can utilize or avail my chopsticks. Only I lay them down. Okay. Now if we correlate the same segment of code with three parameters in terms of counting semaphore, this is how what do you say, the representation goes like this, which satisfies mutual exclusion, having mutex locking mechanisms. All these are counting semaphores and the flag boolean variable to each philosopher with flag for the respective philosophers. Okay, so whenever they are hungry, so firstly the hungry will appear here. Okay, so if they are fast in thinking enough, then this think will override the hungry word, then the think word will appear. And if he is fast in eat, then think के ऊपर eat value or eat word will appear. Okay, in this flow, the philosophers one after the other, they start picking the chopsticks and eat, and if they are done, they simply put them down. Okay, so this is what all about dining philosopher problem. I believe that you understood the basic problem of classical problem of synchronization. When the processes execute concurrently, uh, the problem to occurs how they are synchronizing without any lossy, without creating a situation or without leading the situation to deadlock, neither deadlock nor starvation. How we are providing a sufficient resources where the processes can accomplish their task without any delay. Why? Our main objective is to maximize the CPU utilization and increase the throughput. Okay, if they are fast enough, then this will achieve more and more. Okay, so this is what the basic objectives of important objectives of process management unit. Okay, now there's one more topic is left in this unit, that is monitors. Okay, that is quite a little different compared to the classical problem of synchronization, but we do use the same concepts in overcoming the problems. Okay, some might be having some problem doubts on some topics. So if you have such doubts, let us schedule a meeting whenever you're free, then we'll have a क्या बोलते हैं उसको, discussion over it. Okay, so remember, you will ask the direct question to us, explain classical problem of synchronization. So you're supposed to explain about bounded buffer problem, considering producer consumer, and then reader writer problem. Okay? अगर आपको videos याद है, then uh, uh, by bringing those pictures, imagination, you can explain the topic in a beautiful manner. And lastly, what is that? Dining philosopher problem. So whenever you eat on dining table, so you should remember the dining philosopher problem. Clear? All of you, post your roll numbers in the chat box.